Welcome to the SharkBytes podcast. My name is Roland Knall and I'm one of the co-developers of Wireshark. In this podcast, we will discuss all things about Wireshark as well as topics from the world of packet analysis and SharkFest, which is our packet analysis and developer conference. You will meet interesting people and learn why the truth is always in the packets. Welcome, Johnny and Anand from B-Yond. We are here at SharkFest 2023 US, and we are talking about agility from the company B-Yond. Why don't you guys introduce yourself?
Thank you, Roland. My name is Johnny Ghibril. I'm the Vice President of Product Management and Growth here at B-Yond. We're happy to be here. Thanks for having us. B-Yond started about 6 years ago. We started, with a focus of, as AI and machine learning technologies sort of took hold and became more scalable, we looked at the applications we can put in our space, and we launched B-Yond for that purpose. And over the last 2 years, we've been developing agility, which is focused on automating PCAP analysis specifically. And so we're here, SharkFest, to get some feedback and talk to the community and see if we can learn a little bit from everyone and hopefully contribute as well.
Absolutely. Hello, everybody. My name is Anand, and I'm the Chief Product Architect at B-Yond. And I come from a testing and troubleshooting background myself, worked in network and device integration, function service validation for Tier 1 telco. So happy to be here, and thank you for having us.
You're much welcome. So the product we're talking about today is agility. Can you talk a little bit about it? Especially about the automation part, what does it do? How does it work?
Yeah, there's multiple components to it. I mean, primarily the way we looked at the problem is trying to basically map different call flows that happen in the network, specifically using packet captures, and identifying what does success look like, what does failure look like, where does some intermittent issues happen, and be able to identify them as they occur in the network so that we can bring that information to engineers and really focus on the issues that are very repetitive. Right? The intent is not really necessarily to solve 100% of all issues. There are cases that experts are still very much required, but there are repetitive issues where we find a lot of the engineers we work with spend a lot of hours and a lot of effort trying to resolve, and we feel like a lot of those can be automated, and those are perfect cases for machine learning and AI. We do also apply different methodologies. Obviously, we talked a lot. There's a lot of talk right now about ChatGPT and large language models, and we've applied a little bit of those in our product as well to help with the explainability of the models more or less than any other area.
It's interesting that you mentioned ChatGPT. Obviously, that is the one hot topic around the last year or so in the automation industry, in the software industry, in the IT industry. Played around a little bit with that as well. It has its downfalls. It's not always correct. It has its issues. How did you deal with that?
Yeah, it's a very good question. We get that a lot. ChatGPT came into the forefront over the last few months. Ever since they released GTP2. So we actually did some experiments with those, and what we realized is that ChatGPT and BART, these are sort of pre-trained large language models. They don't perform very well on non-human tasks. They perform extremely well on human tasks like translation and sentence completion and so on. But we tried to use it, for example, to generate sample packet captures. And although the results look really convincing, when you take somebody that's an expert to look at them, realize that they were not really usable. And that's where the hallucination comes in, where it produces results that look quite convincing, but they're not very accurate. So where we've focused our attention more is on what's called open instruction large language models. And those are platforms that allow you to use large language neural networks and generative AI to train them on your specific data sets. And that gives a lot more flexibility. You actually get to provide the data set for the large language model and use these generative AI methodologies to try to create something maybe more specific for what we're trying to do. Now, one of the key things also from an AI standpoint in machine learning for us, now talking a little more about machine learning, is that to some degree, it's a defined universe. It's a massive universe, but it's a defined universe in terms of what we're trying to find, right? And what we're doing today is we're trying to build more and more. It's like a giant chess game or a game of Go, right? There's only so many ways a packet can traverse your network, And if you have every one of them mapped out, technically speaking, you should be able to identify what's happening, right? But obviously, that's a very big universe. So there's that approach, almost treating it like a chess game and trying to map as many moves as possible and try to predict where the packet's going and tackle that in that way. But then you have what we call the labeling challenge, which is, large language models have concept transfers. So you can train it on one set and it can apply that knowledge to a different one. Traditional machine learning and AI, the reason why they haven't blown up like it does, because they don't have necessarily that capability as well as the large language models do. So it's all about experimentation, finding out we can apply. But out of the box, ChatGPT and Bard and similar, they definitely did not perform as we expected them to.
Yeah, I mean, it's interesting that you mentioned the PCAP generation. I did something similar and tried to generate PCAP files. It's always, to some degree, it's correct. To some degree, the hallucination kicks in. So for those of you listening who who are not familiar with the term AI hallucination, basically it's an issue large language models have and don't easily overcome, or are not able to overcome quite easily, quite frankly, is that if they cannot find a direct answer in their training set, they start to combine different information which not necessarily goes together to create a new answer, which in theory sounds cool. In practice, most of the time, just some bullshit comes out.
Yeah, we had one of our data scientists and one of people we work with actually put it as a great analogy. He said, if you had an exam, a test, and it was the final answer, and whether you get it right, it depends on whether you pass or you fail. You're not going to leave it blank, even if you don't know the answer. You're just going to put whatever bullshit comes to mind, and then just so that you can get a few points here or there. And that's how these models are trained. They're trained to produce a result no matter what. And if it's incorrect, obviously we're the product, right, for the free version, right? We're correcting these models so that they could get better results. So it's intentionally trained so that the way the model is developed is it encourages more hallucination than not providing an answer.
Yeah, Wolfram did a quite extensive research about that, and he stated in one sentence what the problem is. LLM models can't say I don't know.
That's true. Yeah.
That's the issue. They can't say I don't know due to the programming, but also due to how they work. That's just not happening. I found it fascinating because hallucination leads to a very, very serious issue where you generate stuff that it comes to this trade-off usually you have with AIs. On the one side, they're a great tool in helping people, helping understanding stuff. But it was made out by a lot of, I would say, journalists and a lot of enthusiasts in the beginning as, well, we can reduce jobs, they can replace that and that. The problem is whatever LLMs are generating, you need somebody with an equal amount of knowledge to ensure that whatever was generated is correct. And I'm looking really forward to whoever will solve that issue. I think he will get a Nobel Prize stat in that moment. In that moment. I don't know in which category, but but yeah, that's for me. It's one fascinating thing that everyone overlooks because it's hard to understand. It's quite hard to understand.
Yeah, I mean, you're absolutely right. Like I said, when we tried to do the PCAP generation, it looked good to me. It didn't look good to Anand because he's the expert, and I'm more on the product side. But for the untrained eye, it would have been very easy to me to take that for granted and use that data. And at least for us in our space, bad data is worse than no data, right? So you will absolutely see a lot of these issues potentially for people over-relying on that. Now, at the same time, I think there are certain areas where it does well, like, a lot of developers use them to refactor code and improve it and reduce lines and all that. That's perfectly okay because they are capable of doing the same task. They're simply reducing the time it takes them to get to that result.
Yeah. No, I've used it for that. You can even write in Wireshark dissector. I mean, I'm going to have a talk on Thursday about exactly that. What you can do with Wireshark with it. You can, for instance, you can load a PCAP and say, okay, I want to filter for every packet that's coming from this IP address, and you get the packet filter, the display filter, which I think is especially useful for people coming new to Wireshark. It's a good learning tool. It's a sounding board. I also heard it compared to, it's pretty much a brainstorming session between you and your computer. You can use it very easily to brainstorm ideas and refine certain sentences and stuff like that. And what I personally like it is when I have texts to write, long descriptions to write, I just copy paste them in there and let it, through answer questions, let it get to a point where I am satisfied with the result. That's true. But one of the things that I'm kind of interested in how you might solve it, or how, if you have encountered it, is LLMs never come to the same result twice. So when you regenerate, you have a different solution. Does this happen with your model as well?
So with our models in the product, we're not using LLMs, except, like I mentioned, we're adding some features for explainability, for example, like I said, because we do use our and there's a varying degree of expertise people using our products. People like Anand who are super experts, and there are also new engineers that are coming in. So we use it a lot for explainability. Like, for example, our models are intended to identify why, if there's a failure or there's a warning within the packet flow. And like I said, we have very much a big focus in the wireless space, especially now with 5G, where testing has gone through the roof and those tasks don't scale. But you're absolutely, we did an experiment where we were asking for explainability, and one of the things we were reinforcing if it was correct or wrong, and eventually, actually, I think it was ChatGPT, I don't remember if it was Bard, actually told us to speak to an expert. That was the final answer. So it did a few explanations and it said, you should speak to an expert in this space. Like at that point it gave up, but that was the best answer it could come up with. So yeah, it absolutely happens. So we're trying to find solutions around these by, for example, querying multiple different LLMs. One of them is home built, like I said, being trained on them. And then we're providing the capability for our users to identify the best response. And I don't know, Anand, you can talk about the reinforcement process a little bit, about how we use, the users to identify what's the best classification maybe.
Yeah, because, machine learning kind of has both capabilities of supervised and unsupervised feedback. So that's where, in these kinds of cases where there's inaccuracies essentially in the models, to gain more confidence from the user, you allow or you give a platform for them to actually reinforce, provide a manual label that is more comfortable for them and what they are, more comfortable, closer to seeing what behavior they have in their networks essentially. So that kind of becomes a very reliable tool essentially coming from an expert directly, instead of relying on like an unsupervised, feedback process. So that in turn bumps up accuracies of the model, and future patterns that are based on similar packets, you get a much higher accuracy essentially. So
do you roll these updates or these reiterations out for every customer, or is it customer specific?
It could be both in a sense, because some, as we know, like Johnny talked about, 5G rolling out, network topologies keep changing. They're sometimes specific to customers as well. So you could say that some patterns are very specific to customers, so you got to, roll out updates for them specifically. But if you look at a service in general, like VoLTE, for example, connectivity or fallback, for, connected cores or something like that, there can be some kind of, knowledge transfer that can essentially happen to correlate an end-to-end flow per se. So some of them, to answer your question, some of them are very customer-specific reinforcements or feedbacks and updates, but some of them are beneficial throughout, like all horizontals. Essentially, the model can be built on certain features that can improve the readability, essentially. So
that opens for me a question, because I'm a software engineer for 25 years, and the majority of this part I used as a software architect, system architect. And one of the things I always look for is supportability. So when you say, okay, you have the same product, but with customer A, it answers differently than with customer B due to different learning models, I assume this leads to really support staff on your end that has to be highly trained and highly perceptive. How do you handle that issue?
It's an excellent point. So like Anand said, I mean, there's a general standardization challenge, when we speak about these things. But this is why, as opposed to taking a knowledge-based approach versus a machine learning approach, which allows you to basically recognize more broad patterns, right? So, and this is exactly why the problem, I think, is being we're trying to solve it now when we couldn't solve it 10 years ago is really the machine learning and AI capabilities wouldn't have given us that capability. We had to basically create custom specific solutions for each customer, which makes it not really a product. It's more like a supported solution, so to speak. Now we still have cases, what we call them standard services, like Anand mentioned, voice over LTE, voice over IP, in some cases voice over Wi-Fi, and then 5G, connectivity, access network, etc. These are relatively well defined with the 3GPP standards, with minor variations from one customer to the next. So we have these models that are constant, that effectively have mapped the standards, and then we look for deviations within customers and start accounting for those on an ongoing basis. So that's sort of a growing model, and then it starts to recognize more and more. And at this point, we've come to a point where we have our models, like for example 5G, where once we put them at a customer, we're at about 80% accuracy right out the gate. And this is where the process that Anand talked about, the enforcement and the feedback, where the engineers get to tell us, this was incorrect, this was correct. It typically takes us a couple of months, and we're well above 90% with a consistent feed. Now, there's another area, what we call special services, and those are exactly what you said. We have a support staff that's highly trained, that's able to take those special services. Take, for example, emergency services. They're configured very differently from one, like let's say O2 in Germany configures their emergency services very different than AT&T, very different than Verizon, different than Comcast, and so on. So in those cases, we take these, from the ground up approach. We use our platform and our ability that's very focused on training models to recognize PCAP flows and categorize them into correct, and those are treated in that way. So we call those special services, and we have that approach for those.
This is a part of one of the key questions I have with AI, because on the one hand, it introduces flexibility towards the customer. It introduces the possibility to really gather a solution that is tailored to the customer's needs and specific to his installation, which I think with machine learning, you're not able to achieve the same thing with a non-machine learning version, because you always be trying. It's a difference, in my opinion. It's a difference in working with a Duplo set than with a Lego set, because you can somewhat tailor with a Duplo set, but you're much more finer detailed with a Lego set. But at the same time, when you do that, one of the things I have with AI, and this is just because my background, whenever I use it, there is a voice in my head that always says, is this really correct? Is this really all? And I know, especially with customers that are high risk of losing out those scenarios, these questions arise on a much higher and much more expensive level. Is there an issue with convincing customers when using machine learning that you're really able to catch? I mean, you mentioned 90% of the solutions, so there's obviously some trade-off where I say, okay, 10% of cases we can't track. But is it harder to argue that you say, okay, we can't track everything? There's 10% you have to catch yourself, because there is still work to be done. And from an, I would say, non-machine learning IT background, you would come in and say, yeah, well, this is the solution that solves all our issues. Let's use that. So that must be a difficult discussion as well.
It is. And there's a lot of education that has to happen. Obviously, like you said, journalism has kind of ruined AI for the practitioners, right? And Anand can add to this because he's directly experienced this. But I mean, one of it is education, right? We have, like you said, we have to educate the customer that this is not intended to solve every possible case under the sun. It's intended to remove the repetitive cases off your plate. And this is the key thing, is that we have the ability with machine learning AI to identify confidence for a prediction, right? If it matches a pattern that I've seen 100 times, the model can tell us I know this is correct, right? So this is what we do with our customers. We actually score our predictions to some degree. And our customers, after a little while, they get to know which areas we perform well on and which we don't, from reporting, from education, from so on. And then those remaining areas, that's where, they're best engineers, that's where we're intended to spend their time. But the beauty of it also is, through this reinforcement process, is once it's identified once by an engineer, we can, I guess, commit that knowledge into a model, whether we do it through a decision tree or we use a random forest. So that's where you sort of combine these different methodologies within machine learning that allow you to do these things. And again, the idea is not necessarily, we know we're not going to replace the engineers, at least not in the short time. The expertise is far too high for sort of a relatively unintelligent model to be able to classify them. But what we find that the problem is, a lot of our best engineers are bogged down just solving the same problem over and over again. Because in a lot of these cases, the engineers that are doing the troubleshooting and the fixing, rarely do they have full, control over the design and architecture and implementation of the network, right? They're simply putting band-aids left and right on where they can. So the idea is just to remove as much of that as possible. And like I mentioned, for us, where we started in the wireless space, come 5G, you can't have somebody manually look at every failure that happens in the network, especially because the intent is to open things up. It's all software driven. You're going to have hundreds of potential vendors in one network, all with all interoperability that needs to happen. There has to be some level of automation that allows you at least to remove the noise and things that you know what they are, and allow the engineers to apply their expertise. I don't know, Anand, if you have any more to add to that.
No, that I completely echo to what you said, essentially. And there's a third category as well where machine learning can essentially help, is sometimes false positives creeping up, right? Where that third degree of classification comes that from a customer experience perspective, everything looks okay, but intermittently there are variations happening in your network. Essentially, that's where machine learning has the beauty of giving additional insights. And that, kind of helps build confidence essentially in customers as well, that the way we approach machine learning is, as Johnny already mentioned, packet capture analysis is quite our focus. So giving that kind of visibility into flows over the network essentially helps them gain the right confidence over time.
I think one of the benefits of a system like yours is that I used to work in machine automation, and I was usually the engineer that was called to the really hard to solve cases. And I would say about 80% of those cases you could not solve, but you could only give a very strong indication what was going on. And depending on the level of knowledge you gathered, you're correct or you're incorrect. The problem is you always had to put the full weight of your own knowledge, of your own whatever behind it, and you had to ensure that people trust your opinion. And this was always a hard fight to do. I think especially in cases like that, it makes the job of some engineers easier because it doesn't take their job away, but it ensures that they don't have to fight every battle. They can leave the 90% and just focus on the 10%. I mean, it's still third level customer support is still a battle every time because the customer never tells you the full story, either because he can't or because he won't. I haven't experienced one customer where I really saw the full picture. And yeah, I remember we had one case in the US where a machine stopped working every 6 months for 1 hour. And that was the case. That was all the explanation we had, due to one device. We knew which device, and every 6 months the machine stopped working. That was a fun part. Yeah, it was quite easy to deduce after a while, but as you said, you had to recognize the pattern. You had to understand the things. It basically came down to environmental issues and a faulty clock on a device board. But yeah. In that case, I think this is absolutely a wonderful tool. And I also think about 90%, as you said, one of the big issues in customer support and supporting a large network is you don't see the trees anymore. You just see the whole forest. And by removing 90% of the forest, you start seeing trees again.
Yeah. And for, again, just sort of falling back on our area of focus, which is in wireless, there's this whole transformation they're trying to drive, which what we call, introducing more performance-sensitive applications for mobility, right? Cellular service has been best effort at best our whole lives, right? And even, it's expected that you can drop a call. It's expected that you can lose your connection for a little while, etc. But if you want...
I would very much argue that it depends on the continent. I would very much, as a European, I would say if you say the same thing to a European, they would look at you funny. Because that's one of the things. When I talk to Americans about cell reception, stuff like that, they always assume, well, yeah, there are gonna be issues. What's the problem? I live in a very mountainous region. I live in a country that's very vast. I always expect to have cell reception. There is hardly any region that I don't. I most of the time also expect to have data reception. Yeah. So it's a difference in perspective.
Yeah, you're absolutely right. It is true. I guess the point is, the idea is there's this push to move enterprise onto cellular service, right? And there's going to be, like you said, I mean, the expectation needs to become across the board, especially for businesses today, because, people are not going to pay a lot more money to get 5G on their mobile phones. That's not where the money is going to come from, but it's a massive investment from a capital perspective, right? Densification, more towers, lower, and so on. We can get into that in a lot more detail. But if we really want to start having drones and Industry 4.0 and all that working on mobile networks, even on networks in general, that level of quality and guarantees that you sign up for is going to have to go way, way, way up. And to do that, there's this question of scale. And again, this is where machine learning really comes in. That question is scale. We can't have 2,000 Rolands walking around solving these problems. At best, we can have 10, 15, maybe, right? And these guys are going to be the ones that have to make sure that they solve these big problems, the hairy problems that are causing massive issues for the network. So again, idea is move as much of that effort away from your best engineers, or maybe even just lower the level of effort required for them to be done, and let them focus on making the network the best it can be.
Yeah, and as you said, as soon as one of those engineers leaves the company, you have a big issue.
Yeah.
You can really kill a company and the customer support with just 2-3 guys going.
Absolutely.
Yeah, I think I have to admit, I went into this. I read your material, and as a avid Wireshark user, whenever a tool comes out that does packet capture, we always go through the keywords, and one of the first things that pops up is pretty much every tool on the planet first says we're gonna map the network, we make it graphic, which was one of the first things you also put on your marketing material. I think it's flashy, but it's at the same time. My personal experience is it's one of the most useless features ever. It's just so you can do a nice report for some people. And I completely underestimated how your product works, because from this talk, I really see the benefit. I really see how it can help. Yeah, removing the trees far enough that you can focus on the small little details.
Yeah, and just tell you, the visualization actually, to your point, the visualization came later because what happened was, as you said, we had some trust issues for our results. So the engineers were saying, how do I know this is correct, right? Because initially the product was developed to simply tell you so the way the product works is it tells you, is there a failure or is there a warning? Where is it exactly in the network, and which network component is responsible for it? And it did that, kind of just by providing the data points. And without fail, we got feedback that said, how do I know this is correct, right? I don't trust the AI. So we built a bunch of flashy stuff on top of it with the intent to help the explainability. But ideally, what we would love to see is our users never look at that stuff. We get to a point where, our best customers today, they simply receive a report in the morning and they look through it and they look at the results that we've provided. And based on those results, they go and make changes on the network. But these are customers we've been with for a couple of years now, and they've developed that trust. But we're investing so much development hours in explainability. Like I mentioned, like the ChatGPT integration, simply to explain, what is the error? Why do we think this is the correct one? It's all about building that trust. But I'm with you 100%. If we could do away with the flashy, we like what we call the headless persona, which is run all of the data from the network through this. Let us tell you where the issues are, and focus on resolving the ones that are difficult. And for the ones that we've developed a lot of confidence, simply pass them on to the remediation engine, and let's keep this thing moving.
I totally agree. It's so interesting to me, because this is something that's always happening. When I did network automations and industrial automations, those are real-time systems. So one of the biggest issues, I would say 99% of the issues, is the jitter in the real time. And usually my analysis would come back with 1 line or 2 line. Between those two devices, the jitter is not good. And I would always get the answer, are you sure? Is there not something else going on? What's happening? So I built a tool that did nothing else than display this answer graphically, and always sent the screenshot. Oh, that's the problem.
Yeah, that's exactly it. You're right. Yeah.
People tend to trust images far more than a text.
Yeah. It's picture conveys 1,000 words, right?
Yeah.
It's much easier to read one.
Really? Is it? Because the engineer then first looks at the picture. No, actually, I think it's the manager looks at the picture. Oh, we have an issue. And the engineer looks at the text and says, oh, that's the issue. But you won't get to the engineer when the manager doesn't agree. That's the point. Now, I find it fascinating because humans are really, at some point, we're just stupid apes with sticks. It's always following the same patterns. No, but that's really cool. So thank you very much, guys.
Thank you, Ravi.
That was very interesting. You're going to be around here for the whole SharkFest, so I hope you have a very productive and successful conversations out on the vendor floor and a lot of contacts. And I'm really looking forward to seeing you the next time around at the SharkFest.
And we'll be here. Thank you very much for having us.
Yeah, thank you for having us.
Thank you.
Thank you for listening to this installment of the SharkBytes podcast. If you want to stay informed about upcoming episodes, please subscribe to our podcast at YouTube or your podcasting platform of choice. My name is Roland Knall. See you next time.